Hello everyone and welcome to today's online class for class 11. Lattice enthalpy cannot be determined directly from a chemical reaction, but indirectly from a chemical reaction it can be determined. It can be indirectly determined with the help of this bond-Haber cycle. Now let's take an example where half Cl2 gas, that is one Cl2 atom, is reacting with one sodium atom in its solid form and producing one NaCl molecule in solid form. Now this reaction is the solid preparation of this NaCl solid, that is the crystal form of NaCl molecule with by combining one chlorine atom in its gaseous state and one sodium atom in the solid state. The energy that will be associated with this reaction is given by delta H F. Now delta HF is the formation enthalpy. Enthalpy change due to the formation of this compound. Now this delta H or enthalpy change is actually the measurement of the energy that has been associated to do this chemical reaction to produce this crystalline form of sodium salt. Now, in thermodynamics chapter, we will actually study in details that the relationship between the energy or the change in energy during a chemical transformation and what this change in enthalpy means. Right now you just remember that delta H is the total amount of energy that is being associated, that is being changed or during this crystallization of sodium salt, during the formation of this crystal sodium salt. Now bond-Haber cycle is suggesting that this entire reaction can happen by combining one chlorine atom with one sodium atom directly to produce the crystal NaCl molecule. It can happen in this one step also, or it can happen via multiple step also. That is, supposedly in this first step, this sodium metal, I am transforming the sodium metal into the sodium atom in its gaseous state. That means we are changing the state of the sodium atom in the solid state to the sodium atom in the gaseous state. So amount of energy is required to do this transformation. Now to do this transformation, the energy is required, that is the dissociation energy, delta HD. The chlorine atom in its gaseous state is intact in here. In the next step, this chlorine atom, this one chlorine atom is gaining one electron. So you have to give electron gain enthalpy EA1 to this chlorine atom. EA1 will be released when the chlorine atom will acquire an electron that will produce then it will produce Cl minus. Sodium in this gaseous state will release one electron, and you need to provide ionization enthalpy in this step only, so that one electron from the valence shell of the sodium is getting released, and as a result Na plus produced. Now Cl minus is produced in gaseous state and Na plus is produced in gaseous state also. So in this step, two main transformation we had done. In one transformation, this sodium metal, sodium atom in gaseous state loses one of its valence electron to produce the sodium plus gas, sodium plus ion in gaseous state. As a result, ionization enthalpy was given to the sodium atom. Or along with this single chlorine atom in gaseous state accepts one electron and produces Cl minus in gaseous state, and as a result, electron gain enthalpy has been released. This EAA has released. Now, in this state, in the medium, Cl minus in gaseous state and Na plus in gaseous state is there. They are combining together and forming NaCl in crystal form. Now, what is happening in here? Cl minus in gaseous state, sodium plus in gaseous state, two oppositely charged ions are combining together and forming crystal form of their salt. This is nothing but crystallization. So during crystallization, as it is a crystallization step, after the formation of this crystal salt NaCl, lattice energy should be released. That is going to happen in here. You will be released after the formation of NaCl in crystal form from Cl minus gaseous state and NaCl gaseous state. Combination of Cl minus and NaCl minus in gaseous state and when they will form this NaCl solid in solid state, this lattice enthalpy will be released because this is nothing but the crystallization state. Born is saying that, Born-Haber cycle says that we can do this entire chemical transformation either through this step, this single step, or we can do this transformation via this multiple step. Whatever the step we will take, the total transformation of energy during this chemical process will be same. Meaning, if I take only the single step to produce crystal NaCl, then the entire amount of energy is the delta H formation. That is delta H formation. This will be equal to the all the energy associated with all these steps that we have done in the second in the second plane type, where we have done 1, 2, 3, 4 multiple steps to produce NaCl crystal. So if we do multiple steps, the total amount of energy will be, in this step, dissociation energy is given delta Hd. In this step, two energies associated. One is electron gain enthalpy, another one is ionization enthalpy, and in the last step, lattice enthalpy is associated. So in the multiple step, the total energy associated is the delta Hd plus delta Ea1 plus IE1 plus U. Born-Haber cycle is saying that this energy associated during the single step formation is equal to the total energy transformation during the multi-step transformation. This is the logic behind Born-Haber cycle, that is delta H formation is going to equal to the all the energy associated in the multiple step. Now, delta H formation or delta H dissociation, electron gain enthalpy or ionization enthalpy can be calculated or can be observed via different methods, but you cannot be directly observed. If we know all the energy, all the amount, all the respective amount, all the energy terms, by putting their respective values, we can easily find out the amount of U that is required during this transformation. Like supposedly for this particular example, delta H is supposedly 500 kJ, delta H is 200 kJ. This one is 150 kJ, minus 150 kJ because the amount of energy is being released. I is 200 kJ. We don't know about U. By putting the respective value in this particular equation, and doing the simplification we can find out the amount of U indirectly for this particular reaction.